Welcome everybody. Hello San Francisco. I'm Adam Nygate from Protect AI. We're today talking about vulnerabilities in the AI supply chain. The AI supply chain is pretty unique. It's pretty different to the traditional software supply chain because it's got whole new types of asset classes, and the way we need to think about security in AI applications is pretty different to how we think about security in traditional software. For example, assets in the AI supply chain include data sets, models, and software. And software is an all-encompassing category of libraries, ML frameworks, or infrastructure type software to help run AI applications. For example, we're thinking about inference servers. We're thinking about ML ops platforms that help with model versioning, artifact storage, and the like. Now, when it comes to data sets, we're thinking about proprietary data sets. So we're thinking about domain-specific data, i.e. patient records in a healthcare setting. The majority of these data sets are collected by enterprises as like first-party proprietary assets, but we should also think about third-party open source data sets that are freely available, large in size to download from the internet from repositories like Kaggle. And lastly, we also have user-provided data sets. So we're thinking about inputs coming from users as they're using our applications that we then have to go train and iterate our data sets on top of. Then we have models. These models are either first-party models or third-party models. So with first-party models, these are typically trained from scratch from those proprietary data sets or from third-party data sets. Or you've got third-party models, open source models that come from repositories like Hugging Face. And typically organizations can download these models and tune these models for their specific needs, leveraging these either first-party or third-party data sets. Lastly, we have traditional software, also as part of this AI supply chain. Here we're thinking about proprietary softwares, APIs, for example, that provide context for models during runtime, or open source software. So we're thinking about self-contained applications like those I mentioned earlier, the Power ML Ops, so model versioning as an example. Or we're talking about individual components, libraries that help with data access, ML frameworks, or for data science and experimentation. Now, the AI supply chain is pretty complex. It's completely interwoven. You have companies nowadays that have leveraged data to train models, to deploy applications that then go and write code. And so it's completely, a loop of interwoven supply chain. So let's get into the supply chain and vulnerabilities in the supply chain. We're thinking about vulnerabilities that specifically affect models and data. So what are these new types of attacks and threat vectors in this supply chain? So the obvious one that everybody talks about is prompt injection. So here we're thinking about taking input from external sources. So this could be users providing inputs to a large language model and trying to trick it to do something it's not supposed to do. Or it could be taking input via third-party sources, something like resource augmented generation. Or it could be even a plugin in your email client that's designed to read emails and summarize them for you. Malicious actors can embed malicious prompts in those emails to trick the model to do something it's not supposed to. Another threat is prompt extraction. Here we think about system prompts being leaked from the context of the running AI application. And this is a form of your IP, and this is a very common attack vector for people to do with applications like ChatGPT or other large language models. Another more nuanced attack is weight extraction and model theft. So here we're thinking about millions of instances of communication by an attacker to a model that allows for them to extract a specific weight in that model so they can create it off-site, so they can steal your model and your IP and replicate your model for themselves. We've also got data extraction. Here we're thinking about training data or sensitive data derived from things like patient records in healthcare that have been used to train the models, right? And via certain attacks, you can actually get the models to regurgitate this sensitive information, this patient data as an example. Recently, we saw something called the poem attack, where if you told the model to just repeat the word poem 1,000,000 times over, eventually it would start spilling over its training data and leaking this sensitive content. Lastly, we have data poisoning. This is an attack vector where hackers can go into these open repositories of publicly available datasets like those on Kaggle's and intentionally manipulate the data in these datasets to make a model that's trained from this dataset misbehave. For example, think about a model that's used in insurance underwriting for car loans. Maybe an attacker wants to infect this data set to make anybody who applies for a car loan with a specific job title receive extremely cheap premiums, car insurance premiums. By manipulating the data set that the model is trained from, they can create a correlation between, let's say, a software engineer and low risk. So when that data set is then used to train a model and somebody applies for car insurance with their job title being a software engineer, the model perceives they are very low risk and so charges them a very small premium. And now let's get into the more kind of traditional software to supply chain. So vulnerabilities affecting supply chain software. As I mentioned earlier, here we're thinking about ML ops platforms and tools like those used for model versioning and model artifacts, but also kind of the individual components, ML frameworks and libraries used to train or to do data science experimentation and the like. So let's look at libraries as an example. Libraries are building blocks, the APIs that your AI applications are built on top of, that teams can leverage to build these ML systems. And these span from individual libraries that help with data loading to entire ML frameworks. Now, why is supply chain software different in the AI context versus traditional building of software? Well, first of all, models are black boxes. We really can't understand or see what they do. In traditional applications, you can always read an application's source code to understand exactly what it's trying to do. And why that is significant is because if an attacker introduces a backdoor to software, we can see that backdoor. We can use static code analysis tools to detect that backdoor and alert it to us. And from a security response perspective, we can understand what that backdoor was doing, and so we can remediate that backdoor and remediate any afflicted systems by that backdoor. However, models are different. They're black boxes. We can't understand really by looking at them what they do. So if a attacker has been able to manipulate the weights of a model, we have no idea what the end results of that manipulation will do. We can't even detect for it. Models are also far more valuable than source code. If an attacker got into your network and tried to download your source code, first of all, we're talking about millions of files. They would have to try to exfiltrate all of these millions of files to steal your IP, right? But not just that. Software is also difficult to build. It requires complex pipelines and compilation tools in order to precisely compile how your software is built. Again, models are different. It's a single file. It's a single file that is the culmination of all your IP. If an attacker is able to download your model, that is all of your IP stolen straight away. Additionally, models and data training pipelines typically are exposed to extremely sensitive data. And they have privileged access to access this sensitive data. So when we think about these MLOps tools that are used to interact with models or these sensitive data, we should make sure that they have high safeguards built in from the beginning to ensure that nobody can exploit this unique exposure to this sensitive data. And this is unique compared to traditional software, as an example. Now, additionally, open source tooling is being built rapidly for AI and machine learning. But it isn't necessarily being designed with enterprise security in mind. Open source maintainers, open source comes as is, without warranties, without liabilities, and so they don't typically have these enterprise security requirements built in mind. For example, like defense in depth and zero trust. And so the impact to any application is compounded by these two facts, by the fact that sensitive data is exposed to these systems and that these open source tooling isn't built with enterprise security in mind. Now, what do we do at Protect AI to research into these threats? I would say it's twofold. So first of all is we detect active exploitation of models in the supply chain. So for example, with our senior security threat research team, we discovered what is now known as the shadow ray attack. Now, RSA is a toolkit for at-scale computation in AI and ML. It's basically a task orchestration engine. So when you need to deploy software or execute tasks on thousands of machines, RSA automates this orchestration and collecting the results from all of these tasks being ran. We detected this attack initially with one of our security research community members, and then it exploded onto the internet by other security research communities replicating our findings and posting about this vulnerability. Additionally, it's important to know that model files are effectively viruses, right? They very often will contain within them vulnerable, malicious, arbitrary code that can be executed just by downloading and running this model file. So, for example, lots of developers are downloading, or lots of ML engineers, ML researchers are downloading models freely from Hugging Face. It's kind of the new GitHub for machine learning. And these models can contain this arbitrary code. The one you download and run these models, it executes this arbitrary code. Additionally, we have our bug bounty community and platform, Hunter. About 15,000 hackers who scour AI and ML supply chain assets to find vulnerabilities. And at the moment, we're finding hundreds of vulnerabilities each month. Now, Protect AI is what's called a CNA, a Certified Numbering Authority. This means that we have the unique authority to credit and publish vulnerabilities that end up into the US government's National Vulnerability Database. And as I mentioned, we're finding hundreds of vulnerabilities each month. Now, on that Shadow Ray attack that I mentioned earlier, we actually found this vulnerability first through an attack that one of our community members found, I would say over 6 months ago. Initially, when we disclosed this vulnerability to the Ray maintainers, the vendor of Ray, they initially said that it was a feature and not a bug. The mere fact that you could, by talking to the API of Ray, get it to execute arbitrary code. And it took us a while to, and only through collaboration with third-party security researchers, did we manage to convince Ray of the impact of this vulnerability and get them to eventually fix it. Now, to address these vulnerabilities in models and data sets and vulnerabilities in supply chain software, we have two solutions to this. The first is called Guardian. So Guardian works by scanning both first-party and third-party AI ML models. So here we're thinking about models that you're either producing yourselves from your own data sets or from open source data sets, or models that you're downloading from Hugging Face. How Guardian works is it has a built-in list of scanners that will analyze the model as first, while it's being downloaded, and second, while it's being deployed to evaluate the models for security vulnerabilities. Any security vulnerabilities it finds, it first alerts the user during installation, but also it double checks during deployment to ensure that accidentally no models are being deployed to production. These models can be sourced anywhere from Hugging Face to internal artifact repositories, for example, AWS S3 or other bespoke model artifact hosting solutions. Additionally, we have our brand new tool, a brand new solution just launched on Monday. It's the world's first AI ML supply chain vulnerability database. Now, we're taking the raw security research that comes from our Hunter community, hundreds of vulnerabilities being discovered each month, and we turn them into rich and insightful security advisories for our customers. Now, what's unique here is because we are the first to hear about these vulnerabilities from our Hunter community, it means that our customers are also the first to hear about these vulnerabilities and can remediate these vulnerabilities in their environments prior to public disclosure. On average, we're able to alert and provide early warning to our customers 1 month ahead of public disclosure. Additionally, we crowdsource not just the identification of vulnerabilities, but also the remediation. We work directly with the open source maintainers of these projects like Ray, like MLflow, like Kubeflow, or even enterprise organizations like NVIDIA to fix all of these vulnerabilities that we're identifying. We also take a unique approach to detection. Typically, the way organizations detect these kind of supply chain vulnerabilities is by doing signature-based matching. What they effectively do is they will create something like an SBOM, a software bill of materials, to identify the components that you use in your software stack, and they have their vulnerability database. And they say, oh, you're using component X, we have a vulnerability that affects component X, that's how we know you're vulnerable. However, this is often a false positive, because even though you're using component X, unless you're using the specific method or function of component X, you're not actually vulnerable. What we, however, is we have built a vulnerability scanning solution, something similar to Qualys or Tenable Nessus. It's based upon an open source solution called nuclei. So we generate these nuclei templates, and you can effectively just point these nuclei templates at your infrastructure and let it go evaluate your AI application, your AI stack, and test that infrastructure for the hundreds of vulnerabilities that we have in our vulnerability space, and it will immediately alert you to any actually exploitable vulnerabilities that are currently running in your network. Today, actually, you can go to sideline.protectai.com to browse our free vulnerability database with all of our publicly disclosed vulnerabilities. And you can also take a look at these vulnerability scanners that I just mentioned. We have some freely available vulnerability scanners for you to try out and test and see how they work for you. This is an example of one of the AI ML security advisories that we create. They're super rich, yet they still incorporate the standards that are used within industry to, for example, measure severity or to classify the specific weakness type of the vulnerability. We also draw out and generate the specific attack path that an attacker would have to take to exploit this vulnerability, so that you can identify the weak links in the chain that you would have to remediate to prevent this vulnerability from being exploited. As mentioned earlier, we generate these vulnerability scanners, and you can see one here running on the screen right now. This is evaluating the AI infrastructure in real time, detecting a critical vulnerability, and alerting the security operator to that vulnerability.